Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course, Virtualization Technology. Let's define virtualization. Virtualization is the creation of a virtual entity as opposed to a true or actual entity. The most common type of entity created through virtualization is the virtual machine, usually housing an OS. In this section we discuss types of virtualization, identify their purposes, and define some of the various virtual applications. Types of virtualization and their purpose. Many types of virtualization exist, from network to storage to hardware and software. The Comptia Security Plus exam focuses mostly on virtual machine software. The virtual machines, VMs, created by this software run operating systems or individual applications. The virtual operating system, also known as a guest or a virtual desktop environment, VDE, is designed to run inside a real OS. So the beauty behind it is that you can run multiple version operating simultaneously from just one PC. This has great advantages for programmers, developers, systems administrators, and can facilitate a great testing environment. Security researchers in particular utilize virtual machines so they can execute and test malware without risk to an actual OS and the hardware it resides on. Nowadays, many VMs are also used in live production environments, plus an entire OS can be dropped onto a DVD or even a flash drive and transported where you want to go. Of course, there are drawbacks. Processor and resources and hard drive space are eaten up by virtual machines, and hardware compatibility can pose problems as well. Also, if the physical computer that houses the virtual OS fails, the virtual OS will go offline immediately. All other virtual computers that run on the physical system will also go offline. There is added administration as well. Some technicians forget that virtual machines need to be updated with the latest service packs and patches, just like regular operating systems. Many organizations have policies that define standardized virtual images, especially for servers. As I alluded to earlier, the main benefit of having a standardized server image is that maintained security configurations will be made to the OS from the beginning, creating a template, so to speak. This includes a defined set of security updates, service packs, patches, and so on, as dedicated by organizational policy. So when you load up a new instance of the image, a lot of the configuration work will already have been done, just as the latest updates to the OS and AV software need to be applied. This image can be used in a virtual environment or copied to a physical hard drive as well. For example, you might have a server farm that includes 2 physical Windows server systems and 4 virtual Windows server systems, each running different tasks. It stands to reason that you will be working with new images from time to time, as you need to replace servers or add them. By creating a standardized image once and using it many times afterward, you can save yourself a lot of configuration time in the long run. Virtual machines can be broken down into 2 categories. System virtual machine, a complete platform meant to take the place of an entire computing, enabling you to run an entire OS virtually. Process virtual machine, designed to run a single application such as a virtual web browser. Whichever VM you select, the VM cannot cross the software boundaries set in place. For example, a virus might infect a computer when executed and spread to other files in the OS. However, a virus executed in a VM will spread through the VM but not affect the underlying actual OS, so this provides a secure platform to run tests, analyze malware, and so on, and creates an isolated system. If there are adverse effects to the VM, those effects and the VM can be compartmentalized to stop the spread of those effects. This is all because the virtual machine inhabits a separate area of the hard drive from the actual OS. This enables us to isolate network services and roles that a virtual server might play on the virtual that a virtual server might play on the network. Virtual machines are, for all intensive purposes, emulators. The term emulation, simulation, and virtualization are often used interchangeably. Emulators can also be web-based. For example, an emulator of a Soho's router firmware that you can access online. You might also have heard of much older emulators such as Ballistic or a DOS box or a RAM drive. But nowadays, anything that runs an OS virtually is generally referred to as a virtual machine or virtual appliance. A virtual appliance is a virtual machine image designed to run on virtualization platforms. It can refer to an entire OS image or an individual application image. Generally, companies such as VMware refer to the images as virtual appliances, and companies such as Microsoft refer to the image as virtual machines. One example of a virtual appliance that runs a single app is a virtual browser. VMware developed a virtual browser appliance that protects the underlying OS from malware installations from malicious websites. If the website succeeds in an attempt to install the malware to the virtual browser, the browser can be deleted and either a new one can be created or an older saved version of the virtual browser can be brought online. Other examples of virtualization include virtual private networks, VPN, physical security authentication models, and virtual desktop infrastructure, VDI, and virtual local area network, VLAN, network design elements. Hypervisor. Most virtual machine software is designed specifically to host more than one VM. A byproduct is the intention that all VMs are able to communicate with each other quickly and efficiently. This concept is summed up by the term hypervisor. A hypervisor allows multiple virtual operating systems guests to run at the same time on a single computer. It is also known as a virtual machine manager, VMM. The term hypervisor is often used ambiguously. This is due to confusion concerning the two different types of hypervisors. Type 1 native. The hypervisor runs directly on the host computer's hardware because this is known as bare metal. For example, examples of this include VMware vCenter and vSphere, Citrix XenServer, Microsoft Hyper-V. Hyper-V can be installed as a standalone product known as Microsoft Hyper-V Server, or it can be installed as a role within a standard installation of Windows Server 2008 or 2 or higher. Either way, the hypervisor runs independently and accesses hardware directly, making both versions of Windows Server Hyper-V Type 1 hypervisors. Type 2 hosted. This means that the hypervisor runs within or on top of the operating system. Guest operating systems run within the hypervisor compared to Type 1. Guests are on one level removed from the hardware and therefore run less efficiently. Examples of this include VirtualBox, Windows Virtual PC for Windows 7, Hyper-V for Windows 8 and higher, and VMware Workstation. Generally, Type 1 is much faster and much more efficient solution than Type 2. It is also more elastic, meaning that environments using Type 1 hypervisors can usually respond to quickly changing business needs by adjusting the supply of resources as necessary. Because of this elasticity and efficiency, Type 1 hypervisors are the kind used by web hosting companies and by companies that offer cloud computing solutions such as infrastructure as a service, IaaS. It makes sense too. If you have ever run a powerful operating system such as Windows Server within a Type 2 hypervisor such as VirtualBox, you will have noticed that a ton of resources are being used that are taken from the hosting operating system. Is not nearly as efficient as running a hosted OS within Type 1 environment. However, keep in mind that the hardware solution requirements for a Type 1 hypervisor are more stringent and more costly. Because of this, some developing and testing environments use Type 2 based virtual software. Another type of virtualization you should be familiar with is application containerization. This allows an organization to deploy and run distributed applications without launching a whole virtual machine. It is a more efficient way of using the resources of the hosting system, plus it is more portable. However, there is a lack of isolation from the hosting OS, which can lead to security threats potentially having easier access to the hosting system. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.